This is an example of zone design for LiDAR-enabled intersection. It's just a starting point though. You'll need to make adjustments to tailor it on a site-by-site basis. We found this works really well for quite a few use cases. Now, it may look like a lot, but it's no problem for LiDAR systems. In fact, this should highlight how powerful and adaptable LiDAR can be. We have several colors here on the map, so I'll go over what those mean. Green, these are zones that typically put in calls to the signal, for example, stop bar, advanced detection, etc. Blue, these are multi-purpose zones, anywhere from wrong way detection, a vector for resolving actual individual traveler movements, overflow, and queue information. Pink, this is our complex zone, essentially where all the movements intersect. There's only ever one of these, but it's used for various things. Orange, these are pedestrian movements. If there were bicycle or bus only lanes, we could add those as well. Keep in mind, this is only a starting point. We can easily add more zones than these later on if we determine there's a need for them. There's almost no cost doing that other than some time. What you want to aim for when designing your zones is reusability. Zones don't have to be for one specific purpose. We can have different algorithms in place that have different meanings when travelers are in the zones. This makes setup a lot less complicated and cluttered. Zone tuning will likely be necessary. This essentially involves changing the shape, position, and overlaps of zone. This tuning compensates for imperfect conditions that can only be tailored on an intersection by intersection basis. Things that may trigger the need for tuning, how the perception software functions. For example, if the perception software is not flagging objects as occupying a zone when it should be, you may need to adjust the zone so it does. This can be due to the algorithms they use to detect if an object is in a zone or not. In the reverse, if perception software is flagging an object in two zones when it should only really register in one, you may need to shrink the zone a bit to prevent this. Another is how drivers behave. For example, drivers tend to pull far ahead of the stop bar. You may need to extend the stop bar zone so that the calls still register. Same for drivers who tend to straddle between lanes. You may have to shrink the adjacent zones a bit to ensure that drivers don't get picked up by both when it doesn't make sense to. You may need to reshape these zones to find if you find that drivers are triggering them for other reasons that are not reasonable to be triggering them. You need to ensure the conflict zone can pick up right turn drivers. That's why you see in the conflict zone overlap in the pedestrian zones in the image here. The zone was pulled up to the areas where the right turn drivers would still be picked up by it when they executed their turns. Some cases may require to create some pretty odd zone shapes. They may look disorderly, but will actually improve accuracy and performance. Zones don't have to be perfectly lined up and symmetrical for them to perform optimally. In fact, the more irregular they are, the more likely it was tuned to optimize its performance. Ultimately, you'll want to sit down for a bit and observe how vehicles behave using the zones, which will guide your adjustments. Although this design was meant for intersections, you could easily apply these concepts to any road type, for example, highways, arterial roads, and roundabouts. Here's some use cases that you can take advantage of with each LiDAR deployment at an intersection. These are definitely not all of them. We're still discovering new use cases that LiDAR enables us to achieve at intersections. These are separated into two columns, safety and efficiency. A really big advantage of the LiDAR solution is it's fairly easy to extend when trying to support many different use cases at once. So as new use cases come out, it's really only a matter of developing the algorithms to process the LiDAR data for those purposes. So you can continue to use the same system long into the future. There are a few use cases I'd like to highlight. Stop bar and advanced actuation with classification filters. Highly utilized feature, especially with focus on VRUs like bicyclists sharing roadways these days. SPM data, we're in the process of completely changing what this offers by leveraging the detailed data that LiDAR can provide us. Extending red clearance for bladed walkers. It's a simple action to help keep pedestrians safer, especially for those not capable of crossing very quickly. Detailed recordings and playbacks of events like accidents or conditions. Tagging objects and tracking specific behaviors. This really allows for some sophisticated applications.